All right, welcome back. In this session, we are going to talk briefly about cloud computing. Okay, again, this is our technology refresh portion of our cybersecurity fundamentals class. And with this cloud computing, we're not going to go very deeply at all. But I would like to always start when I talk about anything. I like to have a definition. Actually, first of all, cloud computing gets its name from it's a metaphor of the internet. When you think about the internet, if you ever seen a lot of your network diagrams, you may have an endpoint and an endpoint, and they all go to this cloud, right? Well, that's where cloud computing means that now we want to start doing our computing in this cloud area. And then let's look at a definition. This is the National Institute of Standards and Technology, NIST. Okay, this is their definition of cloud computing. A model for enabling ubiquitous, convenient, on demand network access to a shared pool of configurable computing resources, such as network servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. Wow, what a definition! It would take me a whole slide deck just to kind of decipher this. So, therefore, I came up with my own definition. I don't know how the NIST will feel about my definition. My definition is that cloud computing is a really cool service delivery model. You're going to go, what? Yes, a really cool service delivery model. See, when we think about business, and here's what I want you to do. I want you to back away from the technical side. I know we want to go techie, and this is tech refresh, but for just a little bit, humor me, and let's forget techie, and let's think like a business. So businesses, they want to be able to deliver services, goods and services to customers. If you think about what has happened with COVID-19, right? That forced a lot of businesses to relook at their service delivery model. No longer are many customers coming in to sit down in a dining room to eat. So now they had to look at, how do I get food to the customers? So they're using things like DoorDash and Uber, other ways to come to deliver food. So restaurants, they had to jump right on this change in their service delivery model. Well, the same thing in with respect to networking from a service delivery perspective. Here's what I mean. So when we think about services, so if we look at our basic computing infrastructure, we have three types of services: software as a service, platform as a service, infrastructure as a service. Okay, we call it the SPI model. There are others, but these are the basic ones we're talking about. Now, many of us are probably familiar with software as a service because we use a lot of these things every day. If you use Google, you use Gmail, Facebook, all of these things are software as a service. And what it means, you don't own it. You don't have to own anything. All you do is have to have access to the internet, and you can enjoy using that service, right? So they've changed, early on, if I wanted to have email, I had to go buy a copy of Outlook, or buy a copy of some type of email um, application that would do that for me. Now I don't have to own that. Because all of that resides in the cloud or in the internet. Facebook, what application do you have to install to use Facebook? None. Right. You just have to have access to the internet. That is software as a service. When we think about platform as a service, now how I usually explain this, and I apologize for not having the PowerPoint here, but how I used to explain this, if you remember in our last session when we talked about basic computing, we said there were three layers, right? Hardware, operating system, applications. Think about cloud computing from the same perspective, but it's an abstraction. Infrastructure as a service, that's the computing, that's the hardware layer. This is where I'm going to get computing power as a service. Platform as a service. This right here, this is our application layer. Operating system layer. I don't want to own an operating system. I want to get that as a service. Software as a service, this is the application layer. So we just talked about the software as a service layer. Now, I know most people have a harder time understanding platform as a service. But if you think about operating systems, okay, now I can get things like Windows Azure, Google has a service, Force.com, to where I can actually produce things without owning the underlying operating system. The best example that I can come up with that is if you are a gaming developer, right? If you know someone that develops games, well, they may want that game to run on a Android device, and they may also want it to run on a Windows or a Apple iPhone device. Well, that developer doesn't want to own the Android operating system. As a matter of fact, you probably can't own it, and that likewise, they don't want to own uh, the iPhone operating system. So for them to develop that software, they can get a software development toolkit from Amazon. I mean, from um, Android, from Google, to where they go onto a website, develop it right there within that operating system. So they don't have to own it, but they can still have the access to an operating system to do that development work. Okay, so that's what that platform. You want to have a platform. So Windows kind of gives you the same thing now. If you think about Windows 365, you know, you don't really have to have that operating system because now they're starting to provide you an operating system as long as you have access to the internet. You can get to infrastructure as a service. Now I don't even want to own the infrastructure. I want to be able to do processing without owning any infrastructure. I don't want to have to own my own servers. That's, so if you're familiar with Amazon AWS, that's what, or AT&T offers that service. Rackspace, to where now they will give you a computing capability without having to own the infrastructure. So when you go to Amazon Web Services, they're going to ask you how much processing speed, how much processing power do you need, and they will allocate server space and charge you by the CPU cycles for that server as it's doing your processing. They can also give you an operating system. Would you like a Windows operating system or operate in this environment? So now I don't have to have servers sitting in my back office to run these different applications. Example of this would be, let's say if I had a tax service, I own a tax company. And if you think about taxes, around April, from February to April, for residential taxes, I'm busy. July to September, I'm pretty busy with business taxes. So do I want to do the investment to own all this hardware that I have to get somebody to maintain, to keep it updated, do all the patching, to do all those things for, when I know that I've got peak times of year I'm going to use a lot of it, but then those off times of year, it's sitting in the back room pretty much underutilized? No. What I want to do is go to Amazon and say, hey, listen, for 3 months, I need this much processing power. I need to be able to run my tax software on this. And they will say, here's just how much it's going to cost. Here you go. I stroke them a check, and when I'm finished with it, I turn the service off, and I don't have to worry about keeping it updated, all that. Infrastructure, platform, software. Really, that's the model, is how can we get those things to you as a service so you don't have to own the infrastructure. How you don't have to own the platform. You don't have to own the application. The service delivery model. So cloud is really about how we deliver services, how services are delivered. Now, clouds are deployed in multiple ways. There's 3 deployment models, actually 4 deployment models when we think about cloud, right? You've got private clouds, and with a private cloud, like I said, that's is a cloud within a single organization. It could be could be multiple customers on or off premise. Okay, just like I have a private cloud at home, I can get to things on my storage device, from the internet. Private cloud that's just accessible to just the people that I want them to have it. So increased security, because here again, it's private, it's closed. You can have a public cloud. That's provisioned for open use by the general public. So if you've got Google, you're part of a public cloud. If you've got, if you're on Amazon, public cloud. Reduce costs, but like I say, there could be some security ramifications because anybody out there can join into that cloud. Community cloud. That's provision for exclusive use by some type of community of customers. Banks, for instance, hospitals. Many times in the area you live, a lot of your local hospitals, they are part of a community cloud where they talk to each other. They're able to share information back and forth in that community cloud. And then you have a hybrid, which is really the most popular. That's what most of us have, is a hybrid, which is the mixture of any of these three, right? You could be two or more of those. Many companies, they have a private cloud, an intranet with a private cloud, and then they also have access to maybe public cloud, and they may also be a part of a community, like say a hospital. It could be a hospitals could have really all three of those types of clouds and operate in a hybrid cloud environment. So what are the components that make up cloud? All right, from a topology sense, speaking topological, I always love to say that word. Cloud components, three basic hardware components: clients, data centers, and distributed servers. When we talk about clients, we can have thick clients, thin clients, mobile clients, okay? When we talk about a thick client, that is when I have, like my desktop. My desktop, it has an operating system. It is fully functional. It can operate all its own as well as get to the internet and get me to my cloud services. A thin client, something that could be like an iPad, or so many times thin clients are like our trusted thin client solutions where it looks like a desktop, but there's nothing in there. You got to accept enough memory and hardware components to get you connected to the internet and manage your keyboard and mouse. But there's no operating system. All your user desktop functions are sitting in the cloud. And then we have mobile assets. Like I said, this is like our phones, iPads, notebooks, things of that nature that gives us a mobile ability, when we're traveling on the road. So those are the clients. So when we look at the clients, now we have our data centers. This is where applications are hosted. These are large facilities with a lot of servers, a lot of storage, and that's where all the hosting is actually done. And now we have what we call distributed servers. And what these distributed servers do, they're the one that actually connect via the internet our clients to the data centers. They're the ones that do the adjudication. So if I want to get to a certain service, I will go to that distributed server. That distributed server says, you need to connect to this data center to access that application. So those are the three basic components of how the cloud components: clients, data centers, distributed servers. So when we look at cloud, now from a business model perspective, here's some things you always want to think about. What are some of the, from a security perspective, what are some of the advantages of cloud security? Okay, one, immediate deployment of software patches. If you've ever worked in a security environment, in an IT environment, this is a full-time job. Software patching, just trying to keep up with patches on all of your enterprise systems is a management nightmare many times. In a cloud environment, they have professionals that do that is their full-time job. So I don't really sit around. I'm not that concerned about how Amazon keeps its servers patched, because that's what they do. They're getting paid for that. So also hardware software redundancy. And here again, not concerned about how many servers Amazon needs in their data center. They make that happen because I'm just buying that service. Okay. Incident response, very timely. If something goes down, good idea, it's going to be right back up. Better utilization of common and hybrid security control providers. So here again, from an enterprise perspective, if I'm using a cloud provider, they're going to also provide me a lot of the security controls that I will need to get my system accredited, because I am inheriting those controls from that common control provider. So there's some of the things from a security perspective. Here again, now with every advantage, there is typically a disadvantage. Here's some of the disadvantages: country or jurisdiction issues. When we think about the internet now, right? It is a global um, network, and it has no boundaries. So there's makes it very difficult, and if there is some type of nefarious activity with your data, and that individual sitting in China, it's very difficult to have some type of legal actions taken on that individual or individuals or those nation state actors, right? Multi-tenant risk. Multi-tenant. This is a term you will hear a lot when we talk cloud. Multi-tenant. And to understand multi-tenant, just think about apartment complexes. All right. If you live in an apartment complex, there are multi tenants in your building. You're not the only tenant. So if have if there are other tenants in your building who are security risk, then they can also pose security risk on your stuff. So if a fire starts in the apartment two doors down, now that can impact you in your apartment. Same thing in a cloud environment, So now you have multiple users who have all of their information many times on one set of servers. So if there's malicious activity, it's possible that malicious activity on their storage can impact what's happening on your storage, especially if the hypervisors aren't protected well, and those types of things aren't done. Malicious insiders. So let's say if that cloud technician at Amazon, he's a little upset because he didn't get the pay raise that he wanted, and becomes a malicious insider threat. So now you start seeing the amount of damage that can be done across multi-tenants, with insider threats. This is the one that you always want to be aware of, so you can let your leadership understand the risk associated with going to cloud. Things like vendor lock-in. With some of the smaller cloud providers, you have to be very aware of your SLA, your service level agreements, because when you're going to move your data to a cloud provider, you want to be sure that you have the contract in place so that if that vendor goes out of business, that you can get your data back and move it to another cloud provider. And you want to be sure you get it back in a format that can be easily moved and integrated with another cloud provider. Vendor lock-in. Got to be very, very careful and really work with your contracting individuals and your users to really understand the data and the sensitivity of your data. This is also where you want to be sure that in that SLA, that service level agreement, things like backup and how quickly can you get to your data in case of an outage, and who actually owns the data, because there are sometimes, if you're not careful, when you put your data on somebody else's cloud, the fine print in that SLA may say that data now is owned by that cloud provider. Just things to be aware of when you're dealing with cloud vendors. And again, ties right into this: the risk of a cloud-based provider failing. If that cloud-based provider goes out of business, do you have the proper controls and protection in place via your service level agreement, your contract with that vendor, of which that you're going to get your data back? Do you need insurance and things of that perspective? All right, so we talked quite a bit at a very thin level on cloud. Less on the technology side, I know, more on the business side, because that's really the power of cloud computing, is that business model. Okay, when we come back, we're going to jump right into networking. See you.